This first exercise is called position, velocity, and acceleration, and you're going to observe the acceleration of this car on this little simulation. It's going to be accelerating up the x-axis at a constant rate of acceleration. And what you're going to do is measure the position at a whole bunch of different times, and from the rate of change of position find the velocity, and from the rate of change of velocity find acceleration. Now, the first thing it has you do in the lab exercise is go to the red scroll bar and set the initial position at 0 and set the initial velocity at 0. So it's going to be starting out at 0 on the x-axis at motionless, and it's going to accelerate down the x-axis. And if I just hit run, you can see it slowly begins to pick up speed and accelerates out that way. But you're not gonna do it that way. You're gonna step it slowly because you want to see how long it takes to go certain distances. Like the first one, let's run it until it goes. So you can hit this step button. And when does it get to 1/2 meter? See, now it's at 1/2 meter, and it's taken about 0.78 seconds. So here is the data table. So at 0 seconds it was at 0 position, and at 0.78 seconds it is at 0.5 meters. And we're going to put in a whole bunch of those. So let me step it some more. And these are individual time steps. There it's at 1 meter, and that's at 1.1 seconds. So at 1.1 seconds, it's gone to 1 meter. Let me do a couple more of these. Stepping it ahead to 1.5 meters position. And that's at 1.35 seconds. So at 1.35 seconds, it's 1.5 meters. Oops. Step it ahead to 2 meters. And at 1.55 seconds, it's at 2 meters. Now let me just do one more. Run it ahead to 2.5 meters. Meters, and what time is that? 1.72 seconds. So now you have information about where the car is as a function of time. Now what you're going to do is, in this first time step between 0 and 0.78 seconds, you're going to find the average velocity over that time step. So the average velocity will be the rate of change of position as a function of time. In other words, the change in position, 0.5 meters, divided by the change in time, 0.78 seconds. So let me just get a Excel file in here. And let me just put some of these data in there. So this is time, position, and velocity average. So at 0, 0.78, 1.1, 1.35, 1.55, 1.72. So it was at 0, 0.5, then 1.5 to 2.5. Alright, so what is the average velocity between 0 and 0.78 seconds? Well, it's the change in position divided by the change in time. So I can calculate that in Excel. I can say, the change in position would be cell B2 minus cell B1, or no, I'm sorry, B3 minus cell B2 divided by cell A3 minus cell A2. So the average velocity in that time interval is 0.64 meters per second. And if I just do this for the rest of these, so it's increasing in speed, right? Because it's constant acceleration. That's what it's. And if I can actually plot the speed as a function of time, highlight that and insert this, and you can see, let me move this over a little bit, you can see that it's a relatively linear increase in speed, right? Because that's what this Excel file is modeling, linear increase in speed. Now what about the acceleration? Well, the average acceleration is the rate of change of velocity, right? Which means, like for this time interval between here and here, it's the change in speed divided by the change in time. So this would be, C4 minus C3 divided by A4 minus A3. So that's the acceleration over that. And now there's variation in there, but it's theoretically this should be constant acceleration because that's what the thing is doing. But it's uncertainty in the measurements of what we're doing that's causing it to be something other than constant acceleration. So this is how you're going to do this. You're going to measure positions as a function of time, and for each time interval you're going to find average velocity and plot that. You're going to plot that, and it's best to plot it in Excel since that's the easiest way to do it. And then you're going to find average acceleration between these time slots, and you're going to put those in. See, this right here will be the average speed which in this time interval. This right here will be the average velocity or acceleration in this time interval, and you'll fill it out like that. You'll do this up to 10 meters, I believe it is. Let's see, yeah, up to 10 meters, and you're going to do those plots. So this is how that works.